Now let's look at radical expressions. A radical expression is an expression that contains a radical. Now a radical, we've talked about, kind of looks like a check mark with a line across the top. And some examples of radical expressions are like root 5, or you could also read it as radical 5, radical a, negative radical 3x, or radical and then a fraction, y squared plus 7 all over y. All of these are examples of radical expressions. Notice they don't have an equal sign. You could also have a radical function, such as f of x equals the square root of x, and then you could graph it. So let's fill in this table of values and then graph the radical off here on the right with a Cartesian plane. Let's provide some values, -1, 0, 1, and 4. I also threw in this -1 here just for demonstration purposes, and I'm also going to just draw one more table here just for, again, demonstration purposes. Let's also put a 9 in here. If we took the square root of -1, we would get an I. And again, we cannot graph complex numbers on our Cartesian plane. So we're going to cross this one out as an example of something we can't graph on our current plane. If we took the square root of 0, we would get 0 out. This is considered the input value that would be the minimum of the domain for the square root. If we took the square root of 1, we would get 1. The square root of 4 would be 2, and the square root of 9 would be 3. Notice that if our inputs are all positive, our outputs are also positive outputs, or range values. So if we wanted to list these as coordinate points, it would be 0, 0, 1, 1, 4, 2, and 9, 3. Now let's graph them. 0, 0 is an option. 4, 2 is an option for graphing. And then I'm just going to count over. I know this is not on the graph, but just to get a trend line, I'm going to go over to 9, approximately, and then up to 3. And then I'm going to connect those dots, and we get this interesting graph. The graph continues to increase. It just increases slower and slower, but it's still increasing. Our domain for this function is, hopefully you've recognized this already, but the domain for our function includes 0, but nothing to the left of 0, to positive infinity. Our range is also from 0 to positive infinity. What this means is the domain can continue going from 0 to the right, and the range can continue going from 0 to positive infinity upwards. Let's take a look at simplifying expressions of the form square root of a squared. If we wanted to simplify each expression, we need to assume that no radicals were formed by raising negative quantities to even powers. What this is basically saying is just look for the principal square root. For this first one, I have the square root of y squared, which is just y. The second one, I have the square root of a to the 10th, which would be a to the 5th. And this last one, I have the square root of 9x squared minus 6x plus 1. I'm going to factor that and see what I get. I get a 3x minus 1 and a 3x minus 1. Notice that this has two binomial factors that match, and so I will have the square root of 3x minus 1 quantity squared. This will give me just 3x minus 1. These are all positive answers. Here are some more examples. And here is an example also of what it would look like if we don't assume we just want the principal square root. We could have plus or minus. So when we have the square root of x plus 3 raised to the second power, this would be plus or minus x plus 3. For the second one, I'm going to factor it. I have the square root of x squared minus 8x plus 16. This would give me an x minus 4 and an x minus 4. So I'm going to simplify that to the square root of x minus 4 quantity squared, which will just give me plus or minus x minus 4 as my simplified expression. This next one is the square root of a to the 8th, which would be plus or minus a to the 4th. And this last one is the square root of y to the 6th. That would simplify to plus or minus y to the 3rd. Now you might be wondering where I'm getting these exponents on the simplified expression. And I'm just going to point that out really quick right now. If I were to rewrite the square root of a to the 8th, we assume that the index, the value in this little check mark, is a 2. So the index can be written as a fractional exponent, where the radicand, a to the 8th, has an 8 in the numerator and the index in the denominator. Since it's an even index, we can assume that there could have been a plus or minus value or number squared to get the a to the 8th. So then we reduce the fraction to 4. This will work for all of these because they're all even indexes. If there's no number in the radical, you assume it's a 2.